All right, so we're going to be looking at developing API plugins in CloudStack today. Yesterday, I delivered a presentation with a customer of SolidFire's, Interroot, on a plugin, a set of plugins actually, a couple GUI plugins, and the underlying API plugin that supports them. And then today what we're doing is we're actually going into more detail from a development standpoint on how to actually build an API plugin in CloudStack, something that actually extends CloudStack's standard set of APIs and allows you to deliver additional functionality to your CloudStack end users pretty seamlessly through CloudStack. So that little star there, you can't read that, I kind of did that on purpose. That is just saying that I specifically did this with the 4.5 version of CloudStack, although probably with 4.4, 4.6, these instructions will probably be unchanged. But just so you know, I did this with version 4.5. So let's see, who am I? I'm Mike Tutkowski. I work at a data storage company in Boulder, Colorado called SolidFire. We develop an all-flash array based on a scale-out technology. And the whole purpose of the system is around delivering guaranteed quality of service on a volume-by-volume basis. So instead of just selecting the normal characteristics like the size of a volume, you can also select characteristics like minimum performance guaranteed and related performance items like that. I don't probably need to go into the rest of this for this particular presentation, but you can always take a look at it on the slide deck at a later point. So why might you want to develop an API plugin for CloudStack? There's several reasons. One of them might be that you'd like to take a third-party product. In my case, of course, I'm going to use my SAN as an example and integrate it in a way that isn't really available today in CloudStack. So I already have storage plugins for the storage area network that I work on, but this is actually an extension around virtual networks and making use of those with volumes in CloudStack. At least that's the reason I developed this particular API plugin. So as an example, that first bullet point for me was we needed to be able to support virtual networks, that virtual networking functionality from our SAN within CloudStack. So you want to use virtual networks in CloudStack. Great, we have that ability from CloudStack's point of view. Now we want to seamlessly go into our SAN and create virtual networks as needed there and make use of those within CloudStack. So that was my particular use case. But in general, whenever you have some kind of third-party product that you want to use with CloudStack and kind of provide sort of a seamless user experience between CloudStack and that third-party product, that's a good candidate for developing an API plugin. Also, you often come up with sort of a decision, I guess. Do you want to try to integrate that more deeply into CloudStack, or do you want to develop this as a plugin? In my case, I couldn't actually change anything within CloudStack to make this happen, and so it was a really good candidate to develop an API plugin for. And also developing an API plugin, just like any other plugin in CloudStack, it kind of decouples you a bit from the development of the core code. So in a sense, you're not on the CloudStack community's development schedule. You can rev your plugins sort of as you need to. So that's another advantage, another reason why you might, in this case, want to develop an API plugin to help integrate some kind of a third-party product. So my particular approach for this presentation is that we're going to be developing kind of just a basic API plugin to give you an idea of how that process works in CloudStack. These particular kind of plugins, they're going to deliver additional commands available through your normal CloudStack mechanisms. So if you use CloudStack to issue, CloudMonkey to issue CloudStack commands, you can use these commands through CloudMonkey the same way that you'd use any of your standard API commands. They're, to the client, indistinguishable from any other standard API command. They just extend CloudStack's range of commands. The client can also discover not only the standard API commands, but also any of your extended API commands through the list API commands, which is that third bullet point. So again, it just kind of emphasizes that these look to clients just like any other CloudStack API command. And you can actually have many API plugins running at the same time, delivering their own set of extended API commands, and this will all just sort of work seamlessly through these plugin mechanisms for API commands that CloudStack makes available. So kind of, I guess, step one here, what we're going to do to make this as easy as possible is take an existing API plugin, and we're going to copy it and make modifications to it. And we'll see how the plugin architecture is designed in CloudStack in the meanwhile. So what I've done here is, this is a screenshot. On the far left is CloudStack's root directory. And we can, might not be super visible on this screen, but the very bottom folder on the left is the plugins folder. I've clicked on that, and then within our middle pane, I've clicked on the API folder. And now within that far right pane, those are all of the existing API plugins that are in CloudStack's repository. So people may have developed their own and kind of kept them outside of the CloudStack codebase. These are the ones that are inside of the CloudStack codebase. And the one that we'll use as a template is the one I've circled. That's the SolidFire one that I developed for Interroot, and that the presentation that I had with Alex from Interroot yesterday was all about. So we'll, as an example, copy that, paste it into the same directory, and then we're going to just rename it to something simple right now, like ABC123. So that's the name of our new API plugin. We'll see ABC123 referenced a lot. So step one, copy, paste, rename it to ABC123. Next, there's a bunch of configuration files that we want to go through before we actually get to the Java code. This is a Maven file, and relative to our new ABC123 folder in its root directory, we want to go and find its POM XML file. So POM is a project object model file for Maven. And there's a few areas that we might consider modifying in this file. The top one, almost certainly we're going to want to modify that one. In my case here, you can see it says Cloud Plugin API SolidFire. We'd want to change SolidFire to ABC123 in this case. And then the name, which is the row right below it, I have it as SolidFire API plugin. Probably in this case, we would just use ABC123 API plugin or something like that. In the middle, that's the version of CloudStack we're targeting. If you're you just copied and pasted this, you're probably actually targeting that particular version anyways. But just kind of wanted to point that out, that that's actually where the version comes into play for the plugin. And that should technically map on to whatever version of CloudStack you're running within. At the bottom are a list of other projects that my new project is dependent on. In my case, I was dependent on the SolidFire storage plugin, which is a distinct plugin from this API plugin. And so I included its project. I'm just pointing this out just to mention that you might have your own dependencies, and this is where they would actually go. Okay, so a few more of these configuration files before we get into the more, in my opinion, the more interesting part, the Java code. So again, relative to this root, the root directory of the ABC123 folder, what we really want to do here is just do a search on, in this case, the name SolidFire, since we copied and pasted that SolidFire project. And we just want to change any instance of SolidFire to ABC123. That's in the folders and the files. So as an example, I have for that first bullet point, Spring SolidFire context XML. We just want to change that to Spring ABC123 context XML. And just kind of do that for all of your files and folders. Anywhere where SolidFire shows up, change it to your own name for your plugin. The second one is that we want to find a particular file called module.properties. And it would be in the resources, so again, relative to your ABC123 folder, it would be in the resources, metainf, CloudStack, now what's called the ABC123 folder. We would find the module.properties file. We'd bring that up and we'd change SolidFire to ABC123. So kind of a little tedious work there, but pretty much just changing, search and replace essentially. Another configuration file that we want to look at, which is actually in that same directory as the module.properties file, is Spring, what will be called ABC123 context XML. And in this file, if you did copy that SolidFire project, you're going to have a bunch of lines at the bottom that have this bean syntax. This is for the Spring framework. What we want to do here is we want to keep, I'd say 3 of them at least. We want to keep the util, the manager, and the service ones that are listed below. All we want to do is make sure that we rename them to make sense with your new project. So anything that was underlined before was basically SolidFire text. We're just changing it to ABC123. These particular classes that they reference off to the bottom right, they don't, well, they either don't exist yet or they've been, we've renamed them when we did our search and replace, but we're going to go into those throughout the course of the rest of the presentation here. So right now, we don't really care if they're in a good state or not. We just kind of want that text to reference those particular classes the way they do in this particular slide. So again, this is kind of a little bit of search and replace, pretty easy stuff here. And let's see, I think this is probably the last one we have to really worry about for search and replace. Actually, this isn't even a search and replace. This is going back to CloudStack's root folder. So not in our ABC123 folder that we made, back to CloudStack's root folder. We want to look in the plugins directory. There's a POM XML file. That's another Maven configuration file. We want to open up that POM XML file and add our new project into it. So there's a bunch of module lines. Really, you can just copy one, paste it in there, and then put in your API /ABC123 information. And now you've referenced your POM file. You've referenced the POM file for the API plugin. And then, I guess, again, relative to CloudStack's root folder, we're going to go in and we need to update dependencies section. It's in, if you're in the root directory again for CloudStack, you'd look in the client folder and then look in the POM XML file, and we want to add a new dependency line here. This is telling the management server that it needs to have a dependency on this particular API plugin, so the management server is aware of it. And we can just see I highlighted in red there that ABC123 part, but you could take a dependency, kind of copy, paste it, and then make sure it sort of looks like what the text is here. All right, now we get into the more interesting kind of Java part and how the plugins are actually designed in CloudStack, what we have to do to make a plugin, implement certain interfaces, or extend classes. And what we can see here is at the very top, we have our client. Maybe this is CloudMonkey, maybe this is some other, one of the many tools that are able to access CloudStack. What they typically do there is they send that kind of REST-like command. So you see HTTP, you've got the IP address, the port number, and then client API. The part that we're extending here comes in with the method component. And I gotta be careful on the stage here, but there's a method. And you can see it says delete ABC123 virtual network. Now that's not a normal CloudStack command. That's one of the new commands that we've made available through our API plugin, or rather that we will make available through our API plugin. And then this is how it will be kind of invoked under the covers by CloudMonkey or some other client. So here we're saying the function is delete the virtual network, and then the ID specifies which virtual network to delete. So very much like you might see for delete a volume, and then this is the volume ID that I want you to delete. It's a very similar pattern. It just provides additional commands that weren't previously present in the CloudStack range of API commands. What that's going to do, as you'd expect, that comes into the API layer, and we'll see an example here of what fits into the API layer. Might be a class like delete ABC123 virtual network command. So for every command that we want to add on to CloudStack, we'll have a corresponding command class. And so that's in our API layer. Below the API layer is where we get into the service layer. This is what actually executes our business logic. So the API layer is aware of the service layer. In I guess, Java terminology, you could see imports in the API code that import business logic from the service layer. The service layer is not aware of the API layer. You won't see any imports of API packages in the service layer. So the service layer, once we kind of take a look at an example there, we'll get into a bunch of examples, but we'll see, I've named these managers. So here an example is there's an interface called ABC123 Manager, and that's implemented by ABC123 Manager impl creatively. And that's part of our service layer. That's actually going to do the logic to, in this case, maybe delete a virtual network. And you can kind of picture that although that functionality can be invoked through the API, that service layer can also be used internally for other purposes in CloudStack. It doesn't have to be directly invoked from the API, but in our case, we're providing an API to enable the invocation of deletion logic for the virtual network. So I guess at a high level here, we see the API layer sits on top of the service layer. The API knows about the service layer. The service layer does not know about the API layer. In the service layer, it does know about the data access layer. The data access layer, which we really won't focus on a whole lot here, it's a little bit more remote from the kind of the contents of this presentation. But that would include things, in our case for CloudStack, like value objects and data access objects. The service layer knows about the data access layer, but the data access layer does not know about the service layer. So you can kind of see that separation of concerns throughout here, where we have an API layer, a service layer, and then a data access layer. And we'll kind of refer to this this architectural design as we go through the slides. We'll see at the top of a bunch of slides, it'll mention if it's API layer or if it's service layer. And there really isn't going to be any reference to data access layers because, again, that's getting kind of remote from the actual content of this particular presentation. So let's see. Another pretty diagram here. Off to the left, this is what we actually see from CloudStack's point of view as to how you implement the API layer for an API plugin. So if we start at the bottom, we have the API, I named it API ABC123 Service Impl class. Oh, by the way, red, which it may be not so easy to see there on the screen, red is a class, black is an interface. A dashed line is just it's optional. You don't have to implement that interface. And I believe in these slides, I actually do implement those interfaces, but those are not required. So at the very bottom, we have our service class. This is for the API layer. It has to extend adapter base. So that's what we see off to its right-hand side. To its left-hand side, it implements an interface, just API ABC123 service. Now that interface can implement API checker. And we'll get into what an API checker is. I guess right now the important part is to know that it's optional. To the upper left is what makes us really an API plugin if we implement pluggable service. And we'll see again the details of what's in that interface, but that is what really makes us an API plugin. If we get to the service layer on the right, and we'll start at the bottom again, we have an ABC123 Manager Impl class, which kind of similarly, it has a implementation of an interface that looks very much like the name of the class. It just, in this case, is ABC123 Manager. Now, that particular interface is going to contain our list of business operations, things that we can do like creating virtual networks, deleting them, creating references to, in my case, SolidFire clusters, or deleting references to those clusters, or editing references. All of that kind of business logic is going to be required by that interface. Anybody who implements that interface has to implement that business logic. The configurable interface at the top is if you want, and again, that's optional, that's if you want to have like settings, global settings or account settings, things that that you can have an end user go in through maybe through the CloudStack GUI and configure. I have a couple quota values and things like that on a per account basis. And so I allow the end user to actually access those settings by implementing configurable. And we'll see in more detail how that actually works. But again, that's optional. Maybe in your case, your business logic doesn't rely on any settings like that. Okay, so we're going to actually start with the service layer and then get into the API layer. In this case, I've got a package, org Apache CloudStack ABC123. I have just imported that configurable interface. So that was the optional interface for our service layer. And what we can see is the ABC123 Manager interface just extends configurable, and then we can take a look at the configurable interface just to get a feel for what it requires. It has two methods, get config component name, and I've provided kind of an example way that we might implement that. This isn't really like super critical. What happens here is if you provide a setting that some other API plugin or some other part of CloudStack has already provided, if you have like a name conflict, you'll get an error message printed out in the log, and it will reference the name that's returned here, the string that's returned here. So this is really kind of for debugging purposes. What I've done is my implementation is to just, whatever requires this to be implemented, I just get an instance of the class and then get the simple name. Now maybe if your name isn't really expected to be unique, the simple name, maybe you'll get the fully qualified name, and it's just something you're going to see in the error log if in fact your settings are not unique. So it's hopefully a very small corner case. The config keys, the git config keys, we'll see how that's implemented on the next slide. That's actually what provides our settings and says if they're at the account level, if they're at a global level, all of those kind of details. So let's go take a look at that. We can see here I have a class ABC123 Manager Impl. And remember back from that slide, a couple slides ago, Manager Impl was on the far right, part of the service layer. It implemented the ABC123 Manager interface, and the Manager interface extended the configurable interface. So here what we're seeing is our Impl class. It implements ABC123 Manager, and we're going to see how it deals with these settings, with these configuration settings. I've got the implementation at the bottom, get config keys. There really is just one config key in this example that I'm using. And you can see here we return an array of config key, and I pass into the array the one and only config key that I have, which is listed at the top as a private static final member variable. So that's our S underscore total account capacity. And then I have all the details here. It's of type long. the name. If you were to look in your account in, say, the CloudStack GUI, go into the settings area, you would see a setting called abc123.total.capacity. The default is 0, which is right below that, and I've given a description for that particular setting. And you can see at the kind of at the bottom of that config key, it's at the account level. So CloudStack will discover configurables like this. It will get out the config keys and make sure that when people need to see things like account settings, that they're seeing all of the appropriate account settings. And I just want this particular setting to be available to administrators who are administering accounts. And so this is just one example of how you might use a config key. In my real plugin, I have config keys for the total capacity that an account can draw from clusters, SolidFire clusters. Also the total minimum, maximum, and burst performance numbers. So there's a bunch of different configuration values. And in this case, for the sake of simplicity, I'm just displaying one of them and kind of showing you how the business layer can make use of these configuration values. So let's take a look now at our service layer ABC123 manager interface. And as we said before, it extends configurable. That's kind of what we just looked at on the previous two slides, the two methods that we had to implement. Now we're going to get into the actual business logic. Since this is the service layer, we would expect some real business methods to be required here. And the two that I've just chosen, I had probably a dozen and a half in the real plugin, but again, for the sake of simplicity, I just picked two. I have a list method and a delete method, both dealing with virtual networks. And all I did here on the far right was I pointed out, since we're not really using Java 8 yet, which has a nice class called optional, a standard procedure we've been using in CloudStack is if the value can be missing, we use a wrapper number type. So the top one is a capital L for like a wrapper long. And if you're doing a list, for example, you could actually pass in null and just list all of the virtual networks, or you could list the details for a particular virtual network. And so to allow that flexibility, we tend to use wrapper classes for numbers. The bottom one, when you're deleting a virtual network, just as an example there, you do have to specify a specific virtual network. And so in that case, it's the primitive long type, requiring someone to actually pass in a valid long. And again, if we were using something a little bit more recent in CloudStack, like Java 8, you could actually get around that a little bit more eloquently. But right now, that's what we're kind of left with Java 7 and earlier. And then just kind of as an example, how might you go ahead and implement one of these business methods? I'm not going to really focus a whole lot on the code there, but it does go ahead and does a bunch of interaction with the database in my particular case. Maybe you don't have any database interaction in your particular business method, but in this case, I mean, so it's not required, but in my case, I do interact with the database. I deal with data access objects, value objects. The thing I do want to point out here, and what I've circled, is that I do not return to the caller a value object. That kind of, if you do return something like that, that is sort of exposing some underlying implementation detail that's not necessary to expose. So our value objects, they all implement interfaces. And this here, ABC123 virtual network, you can see in the code at some point, there is an ABC123 virtual network VO, a value object, which would be tied into some database table. Now remember, ultimately, it could be that this business logic method is going to be invoked by the API layer. And the API layer shouldn't really know about the data access layer. So we don't want to expose those details. And to do that, we're just going to return an interface type. And so at some point in the future, if we really wanted to, we could go and change the business implementation. Maybe instead of using one particular kind of database, we could use another or some other data storage technology, and we could use underlying implementations that differ as long as they implement the same interface. And then our API layer doesn't have to worry about that at all. So that's all I really wanted to point out with this particular implementation rather than going into the exact details of how you delete a virtual network for SolidFire. Is just to try to keep those layers abstracted as much as they can be from each other. And at this point, we're going to actually shift gears, go up a layer to the API layer, and kind of see how is that plugin written. Now that we know a little bit more about the service layer that the API layer depends on, how is the API plugin actually built? Again, we have a package at the top. In this case, it's org Apache CloudStack ABC123. It makes two imports. The pluggable service, which is what actually makes this an API plugin. And then I do show an example of using the API checker. Even though in the final implementation of my plugin, I decided not to use that. And I can explain why it's typically not necessary. But it's still good to kind of have an example and sort of show you that it's available. So in my case, for this, at least for this particular presentation, this API ABC123 service interface extends pluggable service and API checker. And actually, I wonder, maybe I can scoot back here a little bit. I wanted to bring this slide back up again just to kind of show you. We were in the service layer, implementation, interface, optional settings interface. Now we're back over here in the API layer. This is the main class that implements that pluggable service at the upper left. And so that's where we're at right now. I think probably a little helpful to kind of point that out versus just looking at all this text all the time. So that's what we see right here. So we've got an interface extending pluggable service and API checker. Pluggable service just has a single method that needs to be implemented, Git Commands, and we'll see that in more detail in a slide or two. And then the API checker, which I put a little comment above that, like I said before, it is optional. The API checker itself extends an adapter interface, and it requires one method be implemented, the check access. This will pass in the user that wants access to the API command, which is the string. And then you can decide if that's okay, let it go. If it's not, you need to throw a permission denied exception. So I looked this up in the code. It does return a Boolean, but that Boolean is actually never used. The code currently depends on you throwing a permission denied exception if you want to deny the permission. Returning false does nothing, returning true does nothing. It only cares if you either don't throw an exception or you do throw an exception. So that was kind of an interesting point that I didn't see documented, but when I looked at the code, it's just not at all looking at that Boolean. So don't even use it, at least not in 4.5. Okay, so the Git commands. Again, maybe actually let me go back a slide here. So we can see pluggable service has the Git Commands method in the middle. We are going to go ahead and implement that. So remember, our API plugin has a bunch of commands that it wants to extend CloudStack standard list with. This is how we specify which command classes are or make up our extension of CloudStack's API. So the first line in the Git Commands method is kind of boilerplate. We make a list of class of unknown. By making a new array list of class of unknown, we assign it to some variable, and then we start doing adds. In the adds is where we're actually seeing classes that implement our new functionality. In this case, I only have two again, just the list and the delete for virtual networks, but in reality, I really had probably a dozen or so. So here we can see we're adding list ABC123 virtual network command.class, which really makes an instance of the class that describes the list API 123 virtual network command class, and then one for the delete as well. So these are how we tell CloudStack what commands are part of our extended list of API commands. and then we just return the list at the very bottom. So CloudStack will invoke this after it discovers your API plugin. And it knows you have an API plugin based on the fact that you implement that pluggable service interface. Okay, so I was mentioning about why you might not want to implement the API checker interface. The reason is CloudStack already has, and it's actually the third bullet point, it already has a class, in this case called Static Role-Based API Access Checker, and that implements API checker. And CloudStack will discover that class, and that class reads up a file, which is actually bullet point 2. That file has a list, and you can see just one small section of it. And in this case, it's showing my delete and list for virtual networks. It has a list of however many API commands are in CloudStack. And then their associated permission level. So one is just a user can access, let's see here, yeah, a user can access that. So anybody pretty much can do, I'm sorry, one is a root admin can do that. 15 is just sort of the addition of 1, 2, 4, and 8. That's saying everybody can do that particular operation, which makes sense. The delete is something that only a root admin can do. The listing is something that anybody can do. And so unless you have some really special needs for controlling permissions, this actually covers most situations. So you would have to update this file with your new commands. And if that is sufficient, which it was for me, then there's really no need for your plugin to implement API checker. But if you do have some special needs, maybe you want to actually do something aside from looking at the name of the command and the permissions, maybe the name of the user matters or something like, I don't know, can't really think of a good use case off the top of my head, but you do have the ability to customize, control who can actually access your API plugins beyond this if it's needed. And that's where that API checker implementation would come into play. And then the top bullet point really just points out where you can find this file. So it's the commands.properties.in file, and it's at that particular location, client Tomcat conf. And really all I do is I just find some existing lines, I copied, pasted them, overwrote their commands with my commands, and then put in the appropriate permissions and saved out the file. And that was actually sufficient for controlling access to my particular API commands, at least from the API side of things. Now remember, the business layer objects can be used from parts of CloudStack other than the API layer, at least in theory. And so those business layer objects should really have their own way of controlling access. And in my implementation, I do have them control who can access what functionality. So this is really from the API's point of view. The API can kind of curb even invoking your API plugin if it sees that the command that the user wants to implement is not something that he or she has access to implementing. That will just circumvent invoking any of your logic and just send a failure back to the user. Even in theory, if you wanted to, you could make all of your API commands here available to everybody and just get the code to be invoked, and then inside of your own code you could decide, hey, this guy doesn't have permission to do this or that, and throw an exception. So this is just kind of a nice way to circumvent calling your code in cases where that guy just never has access to invoke that particular bit of functionality. Okay, and then this is just an example implementation for, let's say I did want to implement API checker. Inside of my API ABC123 service impl class, I've overridden the check access method, and then I just do some basic stuff. I use the account manager object to see, hey, is this guy a root admin? If he is, sure, he can access things. Now, I did have to return true or false there. Again, remember that's actually ignored. If you don't throw an exception, it's allowed. But if he's a root admin, I'm saying, sure, go ahead, he can do this. If the method name that was passed in is list ABC123 virtual networks, sure, he can do that. Otherwise, I'm going to throw a permission denied exception. Now, this is nothing that I couldn't have done in that file. And so after I wrote these kind of methods, I decided They're really superfluous. There's no need to have these here. I'm not doing anything that the static-based role checker class wasn't doing, so I ended up removing these from my final implementation. But I would like to point out that they're there if you do have special needs. All right, so let's take a look at what an actual command class looks like. In this case, we can see at the public class line, this one's called delete ABC123 virtual network command, and it extends base command. Now there's a bunch of different command classes. I think there's list command, there's a few different kinds of commands. In this case, my delete is just extending the base command. When I have a list command, I extend list command. So I guess it's just instructive to note that there's different kinds of commands, and what you extend is, I would just recommend if you're doing a list, go look at an existing list command and see what it extends. I'm pretty sure it's called list command. The deletes and creates, I think they tended to extend base command. But just be aware that there's different command classes out there. And depending on what you're doing, whether it's a create, a delete, a list, they may extend different command classes. At the very top, I have an annotation, which is just pretty much kind of boilerplate for these type of classes. In this case, it's API command, and then the name equals, that is the name. So delete ABC123 virtual network. On one of the way earlier slides where I showed the client submitting a URL, this is the method or that would be specified. Delete ABC123 virtual network. And that is going to be associated with this delete ABC123 virtual network command class. So that's kind of how you tie in the name of the command that's passed in through the API to an actual command class. And then the description is just something that you might see in maybe our documentation and things like that. We'll skip some of the other properties. At the kind of the middle, there's an @parameter annotation. And this is specifying that this particular parameter, now remember the purpose of this command is to delete a virtual network, and the only thing that we really need passed in is the ID of that virtual network. And it can be specified as either a long value or as a UUID. So really the long value maps to the ID in the relevant table, and then the UUID is ideally completely unique within CloudStack. You can use either one of those, and that's pretty standard in CloudStack. So if you were to delete a volume, you could pass in either the ID or the UUID. And I'm just following the same pattern here. So the @parameter annotation has a few fields here. At the very kind of bottom of that command toward the right, it's just saying that this one is required. And so since I have that required, I just made the type a primitive long, just to kind of have that consistency there that you have to pass in something other, can't be null basically because it's a primitive, it's a number. And then at the very bottom, I have some references to inject this and inject that. So this is using Spring's dependency injection functionality. And if we go back kind of to the early part of the presentation where we had a file where it had a bunch of bean lines, and we had 3 bean lines. These are making use of 2 of those. So one of the bean lines referenced the service class, one of them referenced the manager class, and one of them referenced this util class. So Spring will automatically make an instance of those 3 classes, and in this case, it will inject 2 of those 3 objects into this command class. So that makes it very easy to access that business layer functionality. But for example, by just saying @inject ABC123 manager and giving it some name. And so that's kind of what's going on at a high level here. And then just to kind of show you when you extend base command, there's some methods that need to be implemented. Git command name is one of them. You can just provide there's actually a pattern, kind of what people have established in the past. Let me go back a slide. If you see right here, the S name there, that's just static name, that is actually what is being returned, if I go forward again, in the get command name method. And it just kind of follows that pattern, that naming pattern, I think. Let me actually go back. It was delete ABC123 virtual network response. So the response word at the end is pretty common throughout our code base for that particular field. So I just kind of followed that pattern here. This is one of the things. So like if you're writing GUI code on the front end, when you're actually accessing the response, this is part of the way that you access it. You'll say delete ABC123 virtual network response dot something, and get access to the property that you're interested in. And so that's one of the things that you're returning. The other one, get entity owner ID. This is meant to specify like who owns that resource. So in this case, it's a virtual network. I would say really it's owned by the account that created it. And so really this particular implementation is actually overly simplistic. In reality, what you might do is invoke some functionality on your business layer object and say, hey, for this virtual network, tell me who owns it. And then get back that account ID and return it here. Just, I guess for the sake of simplicity, I was just returning some account ID that I had access to. But in reality, you probably would want to access your service layer and ask it who owns this resource, and then tell the API layer that way through this method. And that's, again, it's another nice way to kind of circumvent your code having to be really invoked at all if somebody invokes this functionality and they're not even part of that account. Well, CloudStack's infrastructure can actually ask your plugin, who owns the resource? This guy's not part of that account? Okay, just tell him he can't perform that operation. It's not going to execute any functionality aside from asking your plugin who owns the resource. And so it's a very streamlined way to kind of return errors to the end user. And then one of the main method here, so let's say you get past this, you do actually have permission as far as being part of the same account to delete this resource. Now, CloudStack is going to allow the execute method, which is the next slide. This is part of your command class. It's going to allow the execute method to be invoked. And this is where you do things like, well, in the beginning, I just do something simple like log what's going on. And then we can see the second line in the try block. That's where I actually make use of that manager, that service layer, from my API layer now to delete the virtual network. So I pass in the ID that I want deleted. The service layer does its thing. As long as it doesn't throw an exception, I get back my virtual network object, which is of interface type ABC123 virtual network in this case. Again, not making reference to any value objects or anything that would indicate where this information is actually stored. So it's just a interface that can be implemented differently if we decide to by the service layer at some point in the future. And then before we actually return that data to the end user, which is ultimately what we want to do, we have to realize that these objects that we tend to pass around within CloudStack, they contain information like for a virtual network, it might have a reference to the SolidFire cluster that it's a part of. The way that's stored inside of this virtual network object is just like a long value that's the ID of a row in the cluster table. Now, if I were to return that to the end user, then they would just know the ID of that cluster that this virtual network belongs to, but they wouldn't know the name, they wouldn't know any of the properties of that cluster. They'd have to take that information and go and re-query the system to get that information. And so to make this, again, more streamlined, there's this traditional kind of conversion process in these CloudStack commands where we take back an object that's typically used for internal processing in CloudStack. And we use like a utility class here. I think I call it, let me see here. Oh yeah, it's ABC123 util. And what I do here is I'm passing in that virtual network object. And what I get back is kind of like an expanded object that I can pass back to the end user. It's something that says, well, this is the virtual network, and it has all of the IDs and all of the information that we have about our virtual network, but it also knows about related objects. Again, is an example of the cluster. In this case, though, it knows not only the cluster ID, but it knows the cluster name. It also maybe knows the cluster quotas and anything that might be useful to the clients, so they don't have to take a single piece of information like an ID and go and requery the system to get expanded information that we could have just passed back to them. And so that's kind of what we're doing there. And I sort of look at that util class. I kind of look at that as a business object, but its business purpose is to take other business objects and convert them into objects that can be returned through the API. So there's really like one business object that kind of has some understanding of the API. I noticed, I remember before I mentioned that generally speaking, we'd like to keep that completely clean delineation between layers. But for the purposes of efficiency within the system, we don't pass around completely expanded objects like that. We kind of wait until we need to actually do that before we expand them out. And that's what this util business object is doing. So there is a little bit of overlap then between the API and the business layer, but just in this one section here. The rest of it we keep nice and clean. Okay, so and then let's take a look at one of those returned API objects just to get a feel for what that looks like. In this case, it's called API ABC123 Virtual Network Response, and it extends a base response class. And then it's pretty easy to make these kind of classes. You typically have a serialized name. So ID is one example, UUID, the name, the size. Those serialized names are what you're going to see from the client's point of view. So if you're a JavaScript client, you're going to use that response name that we saw, and then maybe another name that was passed back by the plugin, and then finally you're going to say .id or .uuid or .size, and that's how you're going to actually access the properties that you're interested in. And so these annotations, serialized name, that's useful for the client. Param description, that's informational to, you can get that kind of information for documentation purposes, and so that's kind of nice from that point of view. But really, you can kind of just picture these response classes. They're pretty basic. They're just a bunch of properties with getters and setters. Not really any logic around that, just get this, set that. And the real important part is that you set them and that they did have a serialized name annotation that is got some kind of field that you want the user to reference on the client side to actually get your property. And so that's kind of what's going on here. And let's see, I'm almost to the final kind of wrap up here, but let's just take a quick peek at that util class. So there was that utility class that we considered a business layer object that takes in other business objects and returns fully expanded API objects. And I know it's probably not very easy to see here, but what we're doing really is we're just making an instance of a response class. So you could picture, like on the previous slide, maybe we're making an instance of this class, and then I'm going to move forward. And then after we do that, we're going to set all of its properties. We're going to, for the virtual network, we're going to set its ID, its UUID. We're going to set the account ID that it belongs to. We're going to go farther than setting the account ID. We're going to set the UUID of the account, the name of the account, all sorts of stuff, so that we just pass all of this information back to the end user, the client, and then it has it all available. It doesn't have to say, oh great, you passed me back the account ID, but I really wanted to display the name, so now I got to go send another query and retrieve that. We're just making it very easy for the client to have all of that information. And so that's all we're really doing here is where we need to, we're looking up, so the account ID, we're looking up the account, and we're pulling out other fields that we think might be of interest to the client, sticking them in this response object, building up the whole response object. You can see kind of at the bottom, there's a response view full, and depending on what you passed in, if you're an administrator, maybe you get access to additional other fields. So in this case, if you are an administrator, we give you the name of the cluster for this particular virtual network. If you're not an administrator, then it doesn't really matter in that case, and we might even want to protect the name of the cluster, and so we won't provide that particular piece of information in the response. So you can see that you just have that flexibility to do a full response or a partial response based on what was passed in by the API layer, and the API layer is going to make that determination typically based on what kind of an account you belong to. So that's just kind of the basics there. A lot of like retrieving information from the database, setting it in the response object, eventually returning the response object, and then we can see if I go back a slide, actually go back 2 slides, we can see our response object comes back. And then we just set a couple extra other pieces of information. We set the command name, which is part of how the client is going to access the properties. And then we also set this object name, which is it's another piece of information in terms of how the client is going to actually access this information. So API delete ABC123 virtual network, that will be part in, for example, in the JavaScript code for the UI of how they might access a property like the UUID of a virtual network. And I just followed an existing pattern for all of these. They tended, for the object name, they tended to start everything with API, and then if it was delete, that was the next word, delete. And if it was a virtual network, you put virtual network. And so it just kind of follows an existing pattern. And then we just set the response object, and we're done. The only, if anything throws an exception in here, we just catch it, print out an error message to the log, and then return a standard API error to the end user. So let's move forward here. I think we have 1 slide. And I guess just for the sake of completeness, for deploying this, once we've compiled the code, we have our jar file. And to deploy it, what we're going to need to do is shut down the CloudStack management server. I think these paths are from an Ubuntu install, I believe. I can't remember if that was the exact OS. But just as an example here, you can see that the jar file goes in a particular class's directory. And then we also want to make sure that what's it called here, the commands.properties file, that was the one that listed the API command equal the access permissions. We want to make sure that we either update that one on that CloudStack management server install, or we take our file that we updated earlier and put it over the top of this one. I guess if you do that, you just have to make sure you're not wiping out anybody else's commands that might be in that file. So maybe the safer route is to bring up the commands.properties on that management server install and then stick in your new list of key value commands for the new properties. Once you have those 2 things in place, really the jar file and the properties file, restart the management server, and then you can go ahead and issue your commands and test out your functionality and make sure everything's looking the way you expect. So great. Thanks for listening. Does anybody have any questions? Yeah?
So let's take the example of SolidFire plugin.
Sure.
There would be some metadata which you use to talk to your SolidFire SAN server itself, management server or something, right?
Correct,
Where
correct.
is that stored?
Good question. So
I saw some get connection.
Yes.
Is that the place?
You know, actually, that's a great question. So I have 3 new database tables that are required if you use my plugin. And so I didn't emphasize those because I didn't want to imply that an API plugin necessarily requires persistent storage. But in my case, it did. You're exactly right. And that information is basically, there's 3 new tables. There's a SF cluster table, SF virtual network, and SF volume. And those are actually, you can create those with a SQL query that has those 3 commands. And then once those are in place, you can run all of your normal commands through the API to create references to a SolidFire cluster, which would be stored in one of those tables. And then based on when you make a new virtual network, you're going to specify the ID of a SolidFire cluster. And we'll look that up then in the SF cluster table, get out the connection information, which you provided when you first made a reference. Yep, exactly. That's a great question. And yeah, the reason I basically skipped it was just to kind of emphasize that you don't necessarily have to have persistent storage for the API plugins, but Oftentimes you will want to, and in this case I made my own tables. Perhaps you might be able to use some of the existing details tables. I investigated that route as well. It just wasn't really robust enough for my particular purposes, but for other people's it may be. It just depends on the use case. Yep.
So is it good practice to keep it within the cloud database or keep it outside?
Well, you could go either way. I was talking to representatives at Citrix about that, and they wanted to make sure from an upgrade perspective, nothing that I did there was going to damage upgrades. And to their satisfaction, they were fine with that and said, yeah, it's fine. We'll go ahead and support Cloud Platform even if it has these 3 tables in there. Alternatively, you could put it in another, like say MySQL instance or whatever you like, really. It was definitely the easiest route was to put it in the existing table because then I could take advantage of all of the existing HA functionality. Mm-hmm. Cool. Any other questions? All right, then I think we're off to lunch. Thanks.